Bill Nye the Science Guy has been getting us pumped about the final frontier and all its mysteries for decades. Bill Nye has piqued our interest in the ultimate frontier and all of its mysteries while introducing us to the vastness of the James Webb Space Telescope. People have been working on this for over 25 years because, as the saying goes, they needed a lot of miracles. Deep space, that surrounds and extends infinitely above us, now takes on new meaning as Bill Nye breaks the silence over the most recent photos from the James Webb Space Telescope. These images provide us a glimpse of the universe from over 13 billion years ago, potentially altering our knowledge of it and perhaps even our perspective on life itself. The James Webb Space Telescope, JWST, is making groundbreaking discoveries about distant planets, galaxies, and more. Webb is not only a scientific game-changer but is also heralded as a worthy successor to the Hubble Space Telescope. What are the JWST images that are defying expectations and theories, and what does Bill Nye have to say about them? Let's find out. Webb was the result of years of labor by NASA scientists and engineers. When it was launched on Christmas Day in 2021, the several steps of the telescope's deployment in the following months went off without a hitch. Within days of the telescope becoming operational in late June 2022, scientists started finding thousands of new galaxies that were older and farther away than any previously known ones. Some of these galaxies may have been discovered over 150 million years prior to Hubble's oldest discovery. The telescope also gathers enough light from celestial objects like exoplanets and forming stars to reveal their composition and trajectories across space. Bill Nye claims that this data has already begun to disclose in great detail the atmospheric makeup of planets hundreds of light-years away from Earth, providing clues as to their potential to support life as we know it. One of the most recognizable views from the Hubble Space Telescope has long been the Pillars of Creation in the Eagle Nebula. While Hubble's telescope, which primarily detects visible light, was able to capture the spectacular clouds surrounding the building, the creation occurring within these clouds remained unseen. This has now been captured by Webb's infrared imaging, showing many protostars as tiny red dots against the smoky background of the pillars, each a cluster of dust and gas many times larger than our solar system. These young stars visible in Webb's photograph have not yet started consuming hydrogen, according to Nye. However, as more material is drawn in, the center of the star gradually becomes denser until it is thick enough to initiate hydrogen burning, causing a dramatic temperature increase of around 2 million degrees Celsius. Different colors were used to depict the largely invisible infrared wavelengths in the photograph. The visible parts of the image are blue to us, while the actual wavelengths would appear red. The hue wavelengths increase with the radiation, with red portions of the image, such as the protostars, generating radiation at a wavelength 6 times that of the human eye. According to Nye, this image not only demonstrates Webb's infrared capabilities but may also shed light on the formation of stars like our Sun. The first exoplanets were found in the 1990s, and today there are more than 3,000 confirmed planets orbiting distant stars. However, only about a dozen of these have been directly imaged. Most exoplanets are so far away that they can only be detected by observing the dimming of their host star's light as the planet passes in front of it. Webb, however, is altering that. It took its first direct picture of an exoplanet in September last year. The planet was identified in 2017 and named HIP 65426b. Scientists utilized Webb's coronagraphs, which exclude the light from the central star, along with 2 of Webb's cameras, several filters, and other equipment to observe it. HIP 65426b has a number of characteristics that make it simpler to see. It is the farthest from its host star of any planet in our solar system, at 100 times the distance from our Sun to Earth. It is also an incredibly massive gas giant, about 12 times the size of Jupiter. Meanwhile, the Phantom Galaxy, elusive in the night sky, is brilliantly visible when photographed with Webb's infrared camera. The galaxy's beautiful spiral shape and star-distributing arms radiate outward from a bright center. Visible in Hubble's optical view of the object, also known as M74, a recent Webb image shows structures resembling heat-emitting dust and gas fibers extending from a bright electric blue center. This new image will reveal the star-forming regions dispersed along the galaxy's spiral arms in infrared light. A stunning composite image created by researchers at the European Space Agency, ESA, as part of the PNGS International Project, combines Webb's longer wavelength observations with Hubble's optical views. This enables astronomers to identify star-forming regions in galaxies, gauge the masses and ages of star clusters, and learn more about the tiny dust particles moving through interstellar space. Webb's recognizable diffraction pattern, an imaging artifact, appeared in a picture of a faraway star known as the Wolf-Rayet star WR140 taken last July. The star is surrounded by a unique ripple-like pattern of concentric rings with a slightly boxy shape. Unlike the diffraction pattern, the rings are actual features. Massive stars nearing the end of their lives shed a significant amount of hydrogen into space. The peculiar shapes of WR140's rings result from the interaction between the star and its companion. Webb was designed to view the universe's farthest galaxies, and in mid-December, researchers announced they had successfully done so. The 4 oldest galaxies spotted by the telescope, seen as they were 13.4 billion years ago, date back to when the universe was only 350 million years old. This is about 2% of the universe's current age. For the first time, scientists can locate such remote galaxies with Webb and verify their ages using the telescope's near-infrared spectrograph, which calculates redshift by measuring the lengthening of light waves caused by the universe's expansion. Webb has also conducted extensive extrasolar planet research, focusing on the gas giant WASP-39b, located 700 light-years away. This planet, 8 times closer to its host star than Mercury is to the Sun, has a thick atmosphere containing sulfur, silicates, and carbon dioxide. This discovery marks the first time CO has been found in an exoplanet's atmosphere, providing clues about the planet's formation and history. Webb's discoveries extend beyond exoplanets. Titan, Saturn's moon, is a fascinating location with rivers, lakes, and seas of liquid methane and ethane. While water ice forms its rocky surface, Webb's observation revealed clouds on Titan, providing data for scientists eager to map its hazy atmosphere and uncover new gases. Webb's imaging of the Southern Ring Nebula has also yielded surprising results. Previously thought to be a simple white dwarf expelling its outer layers, Webb's infrared image suggests a more complex structure encircled by a haze of cold gas. Scientists speculate that a hidden third star is responsible for the nebula's ripple-like shells. Nye suggests that although the partner stars appear to be the source of all the gas and dust, they likely emitted it in specific directions. Finally, Webb detected a peculiar brown dwarf, VHS 1256b. This object, emitting a faint reddish glow and displaying unique atmospheric features, has sand and silica clouds, unusual for a brown dwarf. Webb's observations identified methane, carbon dioxide, and potassium in its atmosphere, hinting at a turbulent environment. In many planetary atmospheres, we observe that the ratio of gases is highly skewed. This pattern suggests turbulent vertical mixing that pulls carbon dioxide up from the depths of the atmosphere, where it combines with methane higher up. According to Bill Nye, astronomers' ultimate aim is to discover planets and examine their atmospheres in great detail. NASA recently shared the James Webb Space Telescope's first spectrum of an exoplanet's atmosphere as part of its initial release of photos and data. This exoplanet, known as WASP-96b, had its atmospheric spectrum created by observing the wavelengths of light absorbed by its atmosphere as the light from its star passed through it during transit. This spectrum allowed scientists to examine WASP-96b's water vapor, clouds, and hazy skies, which was surprising as they initially believed the planet lacked clouds. Located over 1,000 light-years away, this observation provides insight into planetary atmospheres beyond our solar system. In our solar system, water is widespread, and it stands to reason that similar mechanisms could exist on other planets. Methane, which is primarily produced by bacteria on Earth, is particularly intriguing to scientists as a potential sign of life. If methane is found in the atmosphere of a distant planet, it might suggest the presence of living organisms. Until recently, researchers believed that WASP-96b's high sodium levels indicated unusually clear skies. However, new data from Webb has led scientists to revisit both current and past data to better understand these contradictions. Evidence of water on this hot Jupiter-type gas giant, which orbits its star every 3.4 days and has surface temperatures exceeding 1000 degrees Celsius, strongly indicates that it cannot support life as we know it. Bill Nye has spoken about the possibility of discovering extraterrestrial life. If we were to find a planet with an atmosphere containing methane, it might suggest life beyond our solar system, challenging our views on existence and origins. Could another civilization also be using their own telescope to look back at us? The Webb telescope, as an infrared telescope, has a unique advantage over other observatories like Hubble, which primarily uses visible light. Infrared capability allows Webb to see through dust clouds and reveal structures previously hidden, like star-forming regions. One of Webb's recent images revealed merging galaxies that Hubble had previously missed. In this image, a zone of intense star formation is occurring at a rate 20 times faster than in our own galaxy. The active region, identified as IC 1623, releases so much infrared light that Webb's characteristic star diffraction pattern appears in the image. This merging, about 270 million light-years away, may even be forming a supermassive black hole. Another of Webb's images, as described by Bill Nye, showcases tens of thousands of stars in a galaxy 17 million light-years away known as NGC 568. This image allows scientists to observe the galaxy's bright core, which represents a concentrated area of star formation. In comparison, the local group, which contains the Milky Way, is about 5 million light-years from Earth, meaning this galaxy is far beyond our immediate galactic neighborhood. According to NASA, the upper left of the image shows a brilliant bar of white light signifying the galactic core where most of the stars are concentrated. Warm dust heated by intense star formation contributes to the galaxy's bright core. This image allows scientists to investigate the processes of star formation in distant galaxies. The James Webb Space Telescope is currently observing numerous other galaxies in a project dedicated to understanding star formation. One of these galaxies, IC 5332, demonstrates Webb's infrared capabilities, as infrared wavelengths allow scientists to see past the obscuring visual light that would otherwise